Hello everybody, this is Edwin. Next we will spend some time to go over the solution of commercial lighting. This presentation will be divided into four parts. First we'll go over the products and the solution and the functions in this solution to have an overall understanding. Then we'll talk about the features and the advantages, which is the most important part. In the last two parts, we will talk about some application scenarios and also some success cases. Let's go to the first part. This is the software products. Mainly we have one SaaS backend software which is based on web browser and designed for brand owners or operators. It provides abundant management functions such as permission allocation, map configuration, project management, device management, etc. The other one is an app which runs on iOS or Android phones. Through this app, operators can manage the system easily and remotely, such as turn on or off the lights by group or by areas, or make scenarios or schedules. It can also provide reports for energy consumption and alerts for different kinds of events. Here are the main functions and features supported in this solution. Basically, it can be divided into four categories, like energy efficiency, device management, installation monitoring, and health enhancement. Here are listed the core hardware devices in this solution. The gateway is the core device that connects all the smart devices such as lights, switches, curtain motors, or sensors via different communication protocols, for example, like Zigbee or Bluetooth. Then the gateway is connected to the cloud platform by TCP/IP network. The converter and the driver can work with a traditional non-smart light and upgrade the lighting system to a smart one. The difference is that the converter can only control on or off. Instead, besides on or off, the driver can also control the illumination. For example, the brightness, the color temperature. The multi-control switch works similar like a converter, but it can control multiple lights instead of just one. Our SaaS software already integrates multiple kinds of devices for different application scenarios. So for clients from different industries, they can always find the right solution. Here are two common smart light solutions. One option is that we use a smart light directly, such as a Zigbee light or a Bluetooth light. The other option is to change the LED driver to a smart one, and we keep the light. Of course, for a downlight, the driver need to be like a constant current driver, and for a bar light, it works with a constant voltage driver. Here is a smart switch control solution. We can use this kind of smart switches for wall-mounted installation, and we can also provide a multi-channel switch control, which is used for multiple light circuits scenario, for example, a stadium. The last one is an air breaker, which is used for switching a whole area. This is a typical curtain control solution in which we can provide two types of motors. One for like a opening, closing type of motor, and the other is a roller shutter type of motor. Here is the solution for air conditioning system control. For water-cooled air conditioners, we can replace the control panel with a smart one directly. Yet for VRV air conditioning system, we can either use a centralized control gateway to work with the outdoor condenser, or we can use a separated control gateway for each indoor unit. We can also notice that no matter is the air conditioner system or the lighting control system or the switches or the curtains, the topology is similar. These smart devices are connected via Zigbee or Bluetooth to a gateway, and the gateway is registered to the cloud. Of course, if the device can be connected to the cloud directly, for example, if it's on like a Wi-Fi device or NB-IoT device, it won't need any gateway. Next, let's take some time to see the features and the advantages. We provide a comprehensive dashboard for device management. For example, we can check the overall power consumption by daily or weekly or monthly or yearly for all the devices or different kind of devices. And also for the power consumption, we can also make a report by different kind of areas. For example, we can make a report for the power consumption of one building, of the floors, also of the spaces inside every floor. And with this kind of data, we can have an overall understanding of the power consumption status, and based on that, we can make some power saving strategies. Also, we can check the work status, alert information, and abnormal information of the devices or the system. With this kind of information, it's much easier for us to find out the problem and make right decisions. For device control, we need to understand that this solution is designed to control lots of device nodes. So we provide like a very intuitive device control interface. We can place all the devices on the map, and we can select any device, or we can control them by groups, or control them by scenes, and we can control them by schedules or by scenarios. And also the working status of the devices will be feedback on the map directly. This is a typical application for power saving strategy. We can use human presence sensors to control the on or off of the light, which can save power and improve user experience. We can also create multiple scenarios and trigger them by events. For example, when the sensor detects the illumination of the environment is low, a group of lights are turned on automatically. We can also control the scenarios by schedules. With the help of gateway, we can store scenarios in the gateway locally. So even when the internet is offline, we can still run local scenarios across different gateways. We also provide a single light control method with QR code. Users can scan a QR code to be authorized to control the light for his own region. It can be applied for scenarios such as libraries or restaurants, where the client can adjust the brightness or color temperatures as their wish. With this system, we can manage energy consumption very precisely. This helps us to understand the power consumption data for every space. For example, if it's a building or a floor or a room, and enable the client the possibility to deploy power saving strategy. In an actual practice, we can save up to 60% power consumption for a parking lot and 40% for indoor scenarios. This is a smart device replacement. For example, normally in the smart system, you already make a lot of configurations such as groups, schedules, scenarios. If a device fails, you need to replace the device with a new one, and you will need to do all the above configurations all over again. This will take a lot of time, and during this time, the final users will be affected. Also, during the configuration procedure, mistakes can be made. With this feature, the engineers can do the replacement operation in thus, and all the configurations with the failed device will be replaced with the new device automatically. We don't need to do the configurations again. This will save a lot of maintenance time and avoid a lot of mistakes. Based on human presence sensors, we can also generate a heat map which shows the density of personnel flow for further decisions. Besides, we can also calculate utilization rate for each space during defined time period. For example, maybe the utilization rate for this floor is like 30%, and the average utilization rate for this building is like 70%. Then maybe we need to find out the reason why the utilization rate of this floor is so low, and we can make some improvement. This is the work order function. Work orders will be generated automatically when device fails or like abnormal events happens, and the manager can allocate it to different commissioning engineers to process. After the work orders are handled by the engineers, the system will automatically check if it's closed or not, if it's solved or not. This is a feature called AI adaptive sensing. It needs to work with sensors that support delay time configuration. For example, in a parking lot, a sensor is configured to trigger the on or off of a light. When a car is detected, the light is turned on. After a predefined delay time, for example, 60 seconds, the light is turned off. With this AI adaptive sensing feature, the delay time of the sensor will be lengthened or shortened based on the actual flow data. So, for example, during time with a lot of motions, for example, like a morning peak or evening peak, during which a lot of employees will drive their cars out or inside of the parking lot. Then the delay time will be lengthened to keep the light on for a longer time, and during work time with less motions, with less employees activities, with less activities in the parking lot, the delay time will be shortened. So this can save more power consumption and take care of the user experience at the same time. Of course, our commercial lighting software platform provides open APIs, mobile SDKs, and the device connection capabilities to help partners quickly build personalized systems. Our platform is quite open, and we can provide our capability to third-party partners. Next are some application scenarios based on which we can find related clients. For indoor scenarios, our lighting system can be used in public buildings, offices, and industrial buildings, and also retail spaces and villas. Because lighting system is like a subsystem, like a function subsystem for all kind of infrastructures. So basically, we can use this kind of solution in all kind of scenarios. These are the typical outdoor scenarios, for example, like gas stations, industrial parks, stadiums, bridges. At last, let's see some success cases. So this is a success case we did in Guangzhou. Is for like a building, an office building. The main feature is like a centralized control, and also uh, and also the client require us to provide a very detailed power consumption report for the whole building and also for the whole for every floor, and also for every space we need to categorize, we need to like list different kind of power consumptions for different kind of subsystems. For example, this is the power consumption for the lighting system. This is the power consumption for the air conditioning system, and this is the power consumption for other kind of subsystems. Also, in this project, we provide like an alert for the service time for the devices. For example, uh, based on the experience of the maintenance engineers, also based on the data from the manufacturers, from the suppliers of the devices. Basically, we have like a life cycle for every kind of device, and we can set this kind of life cycle data in the SaaS software. And before the life cycle, we can have an alert for the maintenance engineers to, for example, to prepare stock in advance. This is an outdoor scenario. Is a project for Sinopec gas station. The key requirement is to lower the power consumption. Based on daylight and also customer flow, different strategies are applied accordingly. This actually helps the client to lower power consumption and also management cost. This one is also an indoor scenario. It's for libraries. It's similar to the office building project, and the main requirement is like a centralized control for the lighting system, and also the client has an eager requirement for the energy consumption report. Fudan University is a top 10 university in China. We provide our system not only for actual management, but also for as a teaching method for the college students to study IoT technologies better. This is for X-Step flagship store. This X-Step is a very famous sport brand in China. This project is located in Shenzhen. Besides power consumption and device management, the most important requirement is to generate amazing lighting effects to attract more customers. Actually, the customer flow increases more than like 60%, like 30%, and also the stores in the same street are looking for us for the similar solutions. So basically, that's all. If you have any questions, welcome to consult. Thank you very much.